Hi, in this video, we are going to look at the sixth rule for exponents. When we have a fraction, we can move the numbers and the variables from the denominator to the numerator and vice versa. To do this, we need to make the exponent of the variable negative. If we have 1 over a, we know from rule 1 that a is actually a with an exponent of 1. So we can move a to the numerator of the fraction, and we get a to the power of negative 1. If a variable has a negative exponent, we can move it to the opposite side of the fraction and make the exponent positive. If we have x to the power of negative a, we can move x to the denominator of the fraction, and we get 1 over x to the power of positive a. If we have 1 over x to the power of negative b, we can move x to the numerator of the fraction, and we get x to the power of positive b. Let's look at some examples. Simplify the following. 2 to the power of negative 5. Remember that every whole number can be written as a fraction with a denominator of 1. So in this case, we can say 2 to the power of negative 5 all over 1. Now, to make this exponent positive, we move it to the denominator of the fraction, and we get 1 over 2 to the power of 5. In this case, our negative exponent is in the denominator already, so we need to move it to the numerator of the fraction, and we get b to the power of 4 over 1. This is a whole number, so we can write it as b to the power of 4. Please keep in mind that an exponent only affects its base. So in this case, we actually have 3 to the power of 1, x to the power of negative 2. The exponent of negative 2 only affects its base, which in this case is x. To make this exponent positive, we can move x to the denominator of the fraction. We're going to leave 3 where it is because its exponent is already positive. And we get 3 to the 1, which is simply 3, over x with an exponent of positive 2. In this example, we have 4 over x to the power of negative 7. Now remember that when we have a fraction, we are dividing the numerator by the denominator. So 4 divided by x to the power of negative 7. When we move x to the power of negative 7 to the numerator, we are actually going to multiply 4 by x to the power of 7. To do this, we leave 4 where it is, and we move x to the top, and we get x to the power of 7. Let's do another one. 8 to the power of negative 1, x squared, y to the power of negative 3. Now, we said previously that an exponent only affects its base. Here we have 8 to the power of negative 1, x to the power of positive 2, and y to the power of negative 3. X is an exponent of positive 2, so we can leave it where it is. Let's draw in our fraction line, and we can say x to the power of 2. Now we can move 8 to the power of negative 1 to the denominator, and we get 8 to the power of 1, which is simply 8. Then we move y to the power of negative 3, and we get y to the power of positive 3. Please remember to always leave your answers with positive exponents. Let's look at another example. 2x to the power of negative 3 multiplied by 3x to the power of negative 3. The third rule of exponents states that when multiplying, we can add exponents as long as the bases are the same. The base of our exponent is x, and x again over here. So we can add exponents even though they are negative. Let's start by multiplying 2 and 3. 2 multiplied by 3, and we get 6. Now we can multiply our x values. So we have x to the power of negative 3. We're going to multiply by x to the power of negative 3, so we can add our exponents. Negative 3 plus negative 3 becomes negative 3 minus 3. Now we have 6x. Negative 3 minus 3 gives us negative 6. Finally, let's make the exponent of x positive. So we can leave 6 where it is. Let's move our x into the denominator, and we say over x to the power of positive 6. Let's do another one. N squared p to the power of negative 2 multiplied by n squared p to the power of negative 3. When multiplying, we can add exponents as long as the bases are the same. Here we have n and p and p. So let's multiply our n values. And we have n to the power of 2 multiplied by n to the power of 2. So let's add 2. Then we have p to the power of negative 2. And we're going to multiply by p to the power of negative 3. So let's add negative 3. So we say minus 3. Now we can add our exponents. We have n. 2 plus 2 is 4. Then we have p. Negative 2 minus 3 is negative 5. Finally, let's make this exponent over here positive by moving p into the denominator of the fraction. N has an exponent of positive 4, so we leave that where it is. And we say over p to the power of positive 5. The fifth rule of exponents showed us that if we have an exponent outside of the bracket, we multiply it by the exponent of every value inside the bracket. Here we have a 5 outside of the bracket, so we can leave it where it is. So we can say 5. Open our bracket. Inside our bracket, we have 3 to the power of 1 and a to the power of 1. So we can multiply these exponents. We have the base of 3. 1 multiplied by negative 2 is negative 2. Then we have a base of a. 1 multiplied by negative 2 is negative 2 again. And we can close our bracket. Now in our bracket, we have two values with negative exponents. So let's move them both to the denominator of a fraction. So we have 5 outside, open our bracket, 1 over, let's move our 3, and we get 3 squared. Then we move a, and we get a squared. Finally, we can expand our bracket, and we have 5 multiplied by 1, which gives us 5, over 3 squared, which is 9, a squared. Let's do one last example. Here we have 3x y to the power of negative 2, all in a bracket with an exponent of 3, over 6x to the power of negative 2y. Now we've just said when we have an exponent outside of the bracket, we multiply it by the exponent of every value inside the bracket. So in this case, we have 3 to the power of 1 to a base of 3. 1 multiplied by our exponent of 3 gives us 3 to the power of 3. We have x also with an exponent of 1. 1 multiplied by 3 is 3, so we get x to the power of 3. Then we have y with an exponent of negative 2. Negative 2 multiplied by 3 gives us an exponent of negative 6. In our denominator, we can leave it as it is. And we have 6 x to the power of negative 2. Earlier in this video, we said that when we're working with a fraction, we are dividing the numerator by the denominator. We have also said that when dividing, we can subtract exponents as long as the bases are the same. So we have x, and y, and y. And we're going to use this idea to simplify this fraction. So let's start with our actual values. 3 squared is 27. So I can say 27 over the 6 from the denominator. Then we have a base of x with an exponent of 3. Let's subtract negative 2. So minus negative 2. Then we have a base of y with an exponent of negative 6. This y in the denominator has an exponent of 1. So we say minus 1. Now we can add our exponents together. Let's start with our value over here. 27 and 6 are both divisible by 3. 27 divided by 3 gives us 9. I'm going to write it over here. And 6 divided by 3 is 2. Then we have x. 3 plus 2 gives us 5. Then we have a base of y. Negative 6 minus 1 gives us negative 7. Finally, we want to move this y over here and make our exponent positive. So in the numerator of the fraction, we have 9. In the denominator, we have 2. X has an exponent of positive 5, so we can leave this up here. So we say x to the 5. Y has an exponent of negative 7. So we're going to put it into the denominator, and we make our exponent positive. You will see more examples like these in our upcoming videos.